video about factorising simple expressions. Now, factorising is just kind of the opposite of multiplying out. Look at these. These are some examples of multiplying out brackets. You've got 4 lots of x plus 2, then you get 4x plus 8. If you've got 3 lots of 5x minus 2, then you get 15 minus 6x. If you've got 2x into x plus 7, then you've got 2x squared and 14x. Factorising is going the other way. It's looking at this and saying, can I find something that I can pull out, something that goes into both bits of these to pull out of the front? And so you might, looking at 4x plus 8, you can see that 4 goes into this and 4 goes into this. Looking at 15 minus 6x, you can see that 3 goes into this and 3 goes into this. Looking at this one, you might start by seeing that 2 goes into this and 2 goes into this. If you're really quick, you'll spot that 2x goes into this and 2x goes into this. So the game is trying to spot things that go into both bits that you're trying to rewrite. So we'll do some examples now going the other way and see how that might work. Suppose we've got 8x plus 20. You think of something that goes into both this and this. Well, you could say 2. I can get 2's into 8 and 2's into 20. So I'll bring a 2 out in the front and create a bracket and think to myself, what do I need to multiply by 2 to get 8x? And quite quickly we'll get that I need 4x. Now 2 times 4x is 8x. What do I need to multiply 2 by to get plus 20? Well, quite quickly you might get that I need plus 10. So I've gone from 8x plus 20 into 2 lots of 4x plus 10. I've done a factorisation. I'll come back to this one in a minute. I'll come back to it in a minute. Suppose we've got 3x plus 12y. 3x plus 12y. What can you spot that goes into both bits? And I hope you can spot quite quickly that I can get a 3 into this and 3 into this. So what do I need to multiply 3 by to get that? I just need an x. 3 times x is equal to 3x. 3 times what equals 12y? Well, if you're quick, you'll figure that out straight away. 3 lots of x is 3x. 3 lots of 4y is 12y. How about this one? 3x squared minus 7x. What's the thing that goes into both sides of this? Well, it's not a number. I can't get numbers. But I think I've got x's here and x's here. So I think I can get an x out. I can take the x out and I've now got x times what is equal to 3x squared? Well, I think it's 3x. X times 3x is 3x squared. X times what equals minus 7x? Well, I think it's minus 7. All I'm doing here is spotting that you can get something into both bits. When you spot something, you pull it out to the front, create a bracket, and then fill in what's needed bit by bit, bit by bit, bit by bit, to make the multiplying out work. I said I might come back to this one. Well, I'll do that now. Because actually this one, I think you can go further. For this one, I think I can look at this and say, well, hang on a minute, I can get 2's into this as well. So now I'm going to do something that you probably wouldn't ever see, but I can think, let's just now play with this. And I put a big bracket around this, so I'm going to do 2 times whatever I get here, because I think I can get another 2 out. So I think 2 times 2x, and 2 times 5. So I think this is 4x, and 2 times 5 is 10. So I've now taken this 4x plus 10 and I've factorised that. What this whole sequence of complicated looking brackets actually means is 2 times 2 times 2x plus 5. Right? And I can just simply say, well, I'll make that 4. 2 times 2 is 4. 2x plus 5. Now, if you were doing this, you probably wouldn't write all of this out once you've gotten quite good at it. Initially, if you've not done any of these for a long time, or you're coming at it for the first time, it probably helps to write it all out. After a while, you'll get good. And you should, I mean, you might have noticed that, you could go straight from this to that by spotting I can get 4s into 8x and 4s into 20. So I'll pull out my 4 and I'll say 4 lots of what gives me 8x and 4 lots of what gives me 20. There's no right way as long as you get to the right answer. It doesn't matter which way around you go, whether you go here first or go here first. And sometimes doing it like this can be helpful. I'll show you one more before we finish. One more to show you. 2x squared y plus 8x y squared. And this is a bit complicated, but I'm going to make it easy by going bit by bit. I'm going to start by pulling out the 2. It's obvious I can get 2's out, right? So I've got x squared y, 2 times x squared y makes that. And I'm looking at this term, 2 times what makes that, and I'll need 4 lots of xy squared. Notice, I'm not scared by the fact that this is x squared y and this is xy squared. It doesn't matter. They're just a blob of stuff. I've got 2 lots of this blob of stuff and 8 lots of this blob of stuff. And if I bring the 2 out, that means I need 1 lot of this blob of stuff and 4 lots of this blob of stuff. But now I'm going to look at this. I'm going to look at this and think, well, hang on a minute, I've got x's here and I've got x's here, so maybe I can get an x out as well. X times what is x squared y? If you think about it for a couple of minutes, you'll probably see that x times xy is equal to x squared y. And now I've kind of forgotten about my 2 for a minute. I don't worry about my 2. I need it there, but I'm just going to sort of think about it carefully later on. I'm going to come back to it later on. Right now, I'm really thinking about what do I need for x squared y and what do I need for this. So x squared y, bring out the x into xy is equal to x squared y. I've got an x here, so I think I'll leave myself with 4y squared there. You could say I'm finished, but actually no, I think there's room to get something else out. So now I'm just going to leave my 2x and think just about that bracket there. I've got y's in here and y's in here. So I can pull out a y as well. And I think if I pull out a y from this, then I've just got an x left. And if I pull out a y from this, I've just got 4y left. And now I've gotten to the point where I haven't got anything I can get out of here and here together. So this is my final factorisation of this starting point. So there we go. That's how to factorise simple brackets.